So we're asked to find from an equation for a particle, we're asked to find the acceleration of the particle after 2 seconds. And essentially what it's asking is, if you recall, any object in motion, the first derivative is velocity. The second derivative is acceleration. So they're asking us to find the acceleration of a particle after 2 seconds, or essentially exactly at 2 seconds. So let's set this up to find the first derivative of this function. So the first derivative is velocity. And we are going to say that we were finding the derivative with respect to t of this entire function. And we can immediately see that using the sum rule, that the constant will just become a 0. And then we can use the sum rule to individually find the derivative of these. So we're going to have 2 times t to the third. So that's going to become 2 times 3 times t to the third minus 1. And that gives us 6 t to the second, minus the next one, which is 5t to the second. So that's going to be 5 times 2 times t to the second minus 1. So that gives us 10 t to the first. And then finally we have plus 3 t to the first. So that's going to be 3 times 1 times t to the first minus 1, which also becomes 1. So this ends up being just 3. So this is our first derivative. This would be the derivative function for velocity. The next one is going to be acceleration, which takes the velocity function and we take the derivative of that. So it's the second derivative. So we have derivative with respect to t, and we'll say the second derivative. And actually, let me see here. I could rewrite this, and I should have in the first one, say derivative of acceleration with respect to t. So these mean the same thing. And then we'll take the derivative with respect to x of 6 times t squared minus 10t plus 3. And taking them individually, we end up with 6 times 2 is 12. And t to the second minus 1 is just t. Minus 10 times t to the first power is just 10. And t to the first minus 1, well, that's just 1. And then, of course, this constant plus 3 becomes a 0. So we now have our acceleration function. And they asked us to find the acceleration of the function such that at t equals 2 seconds. And there was another unit of measuring here, measured in centimeters. So the motion is measured in centimeters. So our solution for the acceleration at 2 is going to be equal to 12 times 2 minus 10. So that gives us 24 minus 10, and I believe that is simply, let's see, 24 is 14. And this is going to be 14 centimeters per second squared. And I know our professor is probably going to go over this, but when you're taking the second derivative of an object in motion, you are going to end up with, if it's over time, you'll end up with that being time squared. So essentially, after 2 seconds, this object's acceleration is 14 centimeters per second squared. And remember that when you're talking about acceleration is essentially telling you how fast the object is changing. So how fast the velocity is changing, excuse me, at that particular point. So if the object on a graph is moving along and we have 2 seconds right here, what we have just solved for is that exact point its velocity is accelerating at 14 centimeters per second squared. So I hope that helps. Thanks for watching.